This is a quick project support video on how to deal with log transformation, log scales, and generating appropriate graphs when you have highly skewed variables. So I prepared a little data set here that does have a skewed distribution. Let's take a look at this. So we have two variables, treatment and yield, treatment ABC, and then let's take a look at a box plot here. So that's our box plot, and we can see this is highly skewed. That is probably advantageous to transform it before feeding this through an ANOVA. And we also want to make nice graphs that deal with this asymmetry. So let's see what we can do. So the first thing, I don't like if the labels are oriented like this, so I always switch them around here with the less one option. So let's do this. That switches my labels. And I could, my first guess would be to do a log transformation. That already looks considerably better. So this is almost perfectly normal distributed. These not quite. Normally, that's quite typical. You can't always get them all right, but that is definitely an improvement. Just a note that different log transformation here don't really make a difference. So we could try a log 2. And if you observe what happens to the distributions, nothing, right? So this just changes the scale here. You can also try a log 10. Again, we're just changing scales. Nothing is done to our distribution. But what we can do to strengthen or weaken our distribution, if we want to stick with the log transformation, is we can add a constant. So I generally like to keep it above 1, but closer to 1 will give me a stronger transformation. So we can here try yield plus 5 and see how that looks. So that does change things a little bit, but I don't think it's worthwhile. So it's slightly, that's what there was plus. I should do minus here. So that goes in the other direction. Okay, so that looks slightly better. Now we have a long tail here. I think I'm just going to stick with the normal log, and we'll roll with this. So we can now run our analysis of variance, and very nice, we got a significant effect. It's probably this one versus the other two. I'm not going to get into this. I want to continue with the graphics here. So once you have your analysis done, how am I going to display this? So one of the popular charts for predictor variable that's a class variable are of course bar charts, and we can use our scikit-plot library to do bar charts with confidence intervals or standard errors or standard deviations, whatever you specify. So I'm going here with the default standard errors, and I should do this with the log transformed yield because that's what I use in my analysis, and that again shows me no big difference here, but considerable difference. A is considerably smaller. Now if I were to use the original data, and so that's what I do here, so I don't have a log yield, I'm just going to put yield as my response variable. Let's check this out. This would actually be quite misleading, right? So this is not right. Or I shouldn't say that. It's the means on this scale are still the means, so that's not wrong. But it does not take into account the skew and the asymmetry. And if these were standard deviations, that would certainly be highly misleading. That would simply be wrong. So we don't want to do this. So we want to do, we want to have the log. But now I have the scale here from 0 to 5, and if I show this in a PowerPoint presentation and talk about my log yield, a natural log of about 4, what the heck, what is this? And nobody knows. This is hard. That's not a good communication tool. So what we want to put here are actually original units, and for that purpose, because it doesn't matter what kind of log we use, it doesn't change anything. So we can try a log 10 or log 2. These give me better values that I can interpret. And so if we do a log 2 instead, so log 2 of yield is still something that most people don't quite understand, but we can fix this in a minute. We can also try a log 10. And so in that case, a log 10 is actually not that ideal because I got fractions here. So what I would like is preferably just whole numbers. And sometimes if I have very small values, they can also go negative. That's also perfectly fine. But I'm looking for tick marks that are whole numbers. So in this case, I only have one tick mark that is a whole number. So my preference here is definitely a log2. So that's what we're going to use. And I actually want this axis to go to 6. So we'll have a transformed axis here that goes from 0 to 6. That's what we want. And let's take a look. So those are my numbers that we ultimately want as tick marks. And if I want to know what the original numbers are, I need to back transform this. And the way this works, if I have a log scale, I do an exponent. So 2 to the power of these numbers here that we just generated. And if I did a log 10 transformation, it would be 10 to the power of those numbers. So let's run this command here, and we can check out what the values are. So it's 1, 2, 4, 8, 16, 32, 64. So those are the values that we actually want here, because those are the actual kilogram per hectare in our original unit. So we just have to replace those units. And nothing is simpler than that. So what we do here is first of all, we set our y-axis scales to go from 0 to 6. Then we also say that we don't actually want to see that axis, so we'll just don't plot it. So we'll just do a blank here. And we'll also put a proper label here so that people know what it is. A yield in kilogram per hectare. Everything else is the same. So let's do this. So with a log2 yield here, right? And there's our bar chart, but without that axis now. So that axis we put in manually. So we want it in position 2. So this is position 1. This is position 2. You could actually add a third and a fourth axis here. Add sequence 0, 6, 1. So that means from 0 to 6 in steps of 1. And then our labels are these values. So we want the original units on there. And we want to flip the labels, and we want tick marks that point into the negative direction. So let's see how that looks. Very nice. So that's a ticket. That's how you want your bar charts to look like. Nothing is misleading here. If these were standard deviations, they would in fact be asymmetrical, because this axis is changing in scale. So the interval between the tick marks actually doubles with every tick mark. So everything is in good order. This is how you should present results that are log transformed in your analysis, if you want to use a bar chart. Now you can obviously also use a box plot, either the original box plot, or the box plot also has a function that you can transform your axis. It's not so super pretty. And so if you do this, it puts tick marks any way it likes. You don't really have control over that, and they also don't have equal intervals. But that's also a simple and easy solution to show your data. But you can do the same thing here. So we can try a log2 that would first give me the tick marks that we need. So this time we want to go from 3 to 8. So we say our transformed are 3 to 8. Then our back transformed one actually go from, let's check it, 8 to 265, because they are high values, and because these have a long tail. So now we do the same thing. We say we don't want to see the x-axis. We put a label here, and then it's the same axis command. This time we go from 3 to 8 in steps of 1. We put the labels, original values, and flip the labels and put the tick marks to the left. So let's do this. First the box plot without the axis, so that's because we set y-axis no, and then we add the axis, and everything is in good order. So this would actually be my preferred display. So you don't have everything bunched up at the bottom, which is nice. It's a perfectly good visualization with the medians, and the means are actually probably not far off in this particular case because they are transformed. And since we did the analysis on the means and not the medians, it's probably a good idea to add the means to the box plot. So that is also easy. We can just calculate the means of log2 yield with the aggregate command, just like we had it in the descriptive statistics lab. So let's do this. Let's check them out. So these are my means of the different groups on a log2 scale. And then I simply add those as points to my box plot. So this goes from position 1, 2, 3 on the x-axis. And then my data set M, variable x, those are my means. There they are. And now we really have it. So that would be the best way to go about it.